when you don't actually know what they are. Many of you will have come across this topic in further pure mathematics in Year 11, and some others of you might have met it as well. If you have met it before, then you probably don't really want to watch this video. For the others of you, those that haven't actually watched this video, then let's continue. Suppose we have a quadratic equation ax squared plus bx plus c equals 0. And let's suppose that it has roots alpha and beta. Well, if we want to look at the expression ax squared plus bx plus c, let's make that x look a little bit nicer, then we know that that has factors x minus alpha and x minus beta, because alpha and beta are roots. And it would be nice to have an identity. But at the moment, we've got a big problem. We cannot have an identity at the moment because on the left-hand side, we have a times x squared. And on the right-hand side, we have 1 times x squared. Well, that's easily sorted out if we just introduce an a on the right-hand side. Now we have the same number of x squareds on each side. If we multiply this out, we will get ax squared minus a alpha x minus a beta x plus a alpha beta. Well, let's just sort that out a little bit. Ax squared minus a times alpha plus beta times x. Just have a look at that. If you multiply it out, you get the line above, so that's all right. Plus a alpha beta. Well, if this is going to be an identity, then if we look at the x squareds, we've already got a equals a, so that's fine. So let's now just look at the x's. On the left-hand side, we have b. And on the right-hand side, we have minus a times alpha plus beta. And so if we take the two roots alpha plus beta, that is the sum of the roots, which is alpha plus beta, that is equal to minus b over a. And that's the first result that we pick out from this. If we look at the constant term, or the coefficient of x to the naught, whichever way you like to think of it, you get c equals a alpha beta, and that gives us that the product of the roots is alpha beta is c over a. Now those are the two results which we really want to hang on to. That isn't going to work, sorry, let's try this one. Nor's that, yes it might. It did work. We got an extra bit of red on the implies sign. So the sum of the roots is alpha plus beta is minus b over a. The product of the roots is c over a. There are one or two things which you're expected to be able to do, and I'll do an example just to show you the first tricks of the trade. Let's suppose, first of all, that alpha and beta are roots of the quadratic equation 3x squared minus 2x plus 1 equals 0. If that's the case, by what we've got at the top of the page, the sum of the roots, alpha plus beta, is minus b over a. That's minus of minus 2 divided by 3. So that's plus 2 over 3. And the product of the roots, alpha beta, is equal to c over a, which is c divided by a, 1 over 3. The first thing, or the first type of problem that you're likely to meet, is to find alpha squared plus beta squared. Why don't you just pause the video for a moment and see if you can find alpha squared plus beta squared. Go on, pause it. Well, did you pause the video? I hope you did, and I hope you managed to find out how to find out alpha squared plus beta squared. The first thing that we need to look at is the fact that alpha plus beta squared is alpha squared plus 2 alpha beta plus beta squared. That tells us that alpha squared plus beta squared, I've written x squared, alpha squared plus beta squared. If I subtract 2 alpha beta from each side, I get alpha plus beta squared minus 2 alpha beta. Alpha plus beta is 2/3. Alpha times beta is 1/3. 2/3 squared is 4/9. 2 times 1/3 is 2/3. That is 4/9 minus 6/9 minus 2/9. Just in passing, notice that alpha squared plus beta squared has come out to be negative. That means that in this particular case, the roots that we're dealing with are complex numbers. Okay, this time let's find alpha cubed plus beta cubed. Again, pause the video. You've got a similar idea to work this one out, so pause the video now and try and work it out. Well, the technique above suggests that we try alpha plus beta cubed. If I want to cube something like that, I think of Pascal's triangle, and we have 1, 3, 3, 1. So let's use Pascal's triangle to work this out. We know we have an alpha cubed. We know we have an alpha squared beta. We know we have an alpha beta squared. I've still got it wrong. Alpha beta squared. And we know that we have a beta cubed. We then pop in the numbers 1, 3, 3, 1. And that is how you should really be thinking if you're expanding alpha plus beta all cubed. Subtract 3 alpha squared beta and 3 alpha beta squared. Subtract that from both sides. Write it down the other way round. Alpha cubed plus beta cubed. Alpha cubed plus beta cubed is equal to alpha plus beta cubed minus 3 alpha squared beta minus 3 alpha beta squared. I'm going to stay on this line because it allows me to look up at the top. I've got alpha plus beta cubed minus 3 alpha beta times alpha plus beta. Okay, what do we know? We know that alpha plus beta is 2/3. We know that alpha beta is 1/3. So putting those together, we get that this is equal to alpha plus beta cubed is 2/3 cubed, and alpha beta is 1/3. Alpha plus beta is 2/3. So that is 8/27 minus 2/3. And that is minus 10/27. Now let's have a look at another type of problem you're expected to be able to handle. I've reminded you at the top of the page that if we have ax squared plus bx plus c equals 0 with roots alpha and beta, sum of the roots is minus b over a, product of the roots is c over a. Okay, let's have a look at the problem below. If alpha and beta are the roots of 2x squared minus 4x plus 1 equals 0, find the quadratic equation with roots 3 alpha minus 1 and 3 beta minus 1. Well, I'm going to put gamma, that's the Greek letter gamma, equal to 3 alpha minus 1, and I'm going to put delta equal to 3 beta minus 1. My aim is to find gamma plus delta. That is now the sum of the roots. That will be my new minus b over a. And I also want to find gamma delta because that will be my new c over a. Right. Not a terribly difficult thing to do, so let's go ahead. Move up, give myself some space at the bottom. We want gamma plus delta. Well, before we can do that, we really ought to find out what alpha plus beta is. Alpha plus beta is minus b over a. B is minus 4, a is 2. So that is minus 4, that's 2. Alpha times beta is c over a, which is 1 over 2. Now I'm in a position to look and see what gamma plus delta is. Gamma plus delta is 3 alpha minus 1 plus 3 beta minus 1. That's 3 times alpha plus beta minus 2. Alpha plus beta, if we look just above, alpha plus beta is 2. That is equal to 3 times 2 is 6, which is 4. And so gamma plus delta is 4. That tells me that my new minus b over a is 4, or I prefer to write that b over a is minus 4. What about gamma times delta? That is 3 alpha minus 1, 3 beta minus 1. That gives us 3 alpha times 3 beta is 9 alpha beta, minus 3 alpha minus 3 beta plus 1. Factorize that to make it easy to handle. And I get that. I know that alpha beta is a half. I know that alpha plus beta is 2. So I've got 4.5. 4.5, 5.5 minus 6 is minus a half. This tells me that my new c over a is equal to minus a half. Or just writing it so that it actually is obvious. I can pick it out easily later on. Now we want the quadratic equation which has gamma and delta as roots. We know all about the quadratic equation, I hope. ax squared plus bx plus c equals 0. My new b over a at the top there is still just in sight, is minus 4. My new c over a is minus 2. Many people find it helpful to write this equation as x squared plus b over a x plus c over a. And so now it's easy to write down the new equation. X squared, b over a at the top of the page in red is minus 4. C over a in red is minus a half. Multiply by 2 to make it look nicer. And there is the equation which has roots 3 alpha minus 1, 3 beta minus 1. Done all that without actually having to work out the roots at all. There is no chapter in FP1 on this. It was introduced into the syllabus after that particular course had finished. But on the website, you will find a link to some resources which have some theory for you and, of course, some questions.